So this code here is actually completely identical to our first line. And as you can see, the value here increases from 0 to 1 to 2, kind of like an index. So an enum is essentially just a bunch of constants with an increasing value, which means that if we try to print one of these states, say we print alignment dot enemy, the console simply shows the value we call key value pairs. Let me explain level with a we make sure to put it at the top, outside of any functions. So this is a script-wide variable. This can be accessed anywhere in your script. If you want converting from one type to another is called casting. For example, now by default, note however that this automatically truncates the number. It does not round. It simply gets rid of the decimals. So 3.9 also a variable will allow us to set it using the inspector. The value that we set in the script will just be a default value. So if we save this and select our node, we can set a value in the inspector. If we print our damage, we can see that this
world, this is a very big change which I'm about to go over. So, you know, for the traditional player, we use a kinematic body. If you look up kinematic body, there is nothing because it no longer exists. So for the player, we now need to use a character body to be. It's basically the same as a kinematic body, but I think it actually is the same as a kinematic body, it's just a character body to be. And we have a Sprite 2D, which does the same thing as it has always done. pretty sure there was a way to do this in the old Godot, but it is cool that this is like the default movement for the box, which I like it more than the old Godot. So that's pretty cool. But for our character, we can name him our player, because this is going to be our player, and we're going to create a player script. And the first thing you know is we create a player script. You see all this code, right? Under the character body, you see all this code. This was never in the last one. You just had like a little ready function, I think, and then that's it. But now they have like an entire movement system, right? So they direction prints UI left. UI left. We'll see kind of how this works. Right, input.x, which is going to be our direction. So if it's a negative one, we're going to go left. If it's a positive one, we're going to go right. If we're going right, then that means it's true, right? So it's going to return a 1. And obviously, if we're going right, we're not going to be going left. So what that will do is that will return a positive 1, so we'll go right. But if we're not going right and we are going left, then that means it's going to be 0 minus 1. So we're going to be going our input. X is going to equal to negative 1, which is going to be the direction the x-axis that we're going to go, and then it's going to make our character go left. Same thing with the y-axis. So we can do here input.y, and instead of right, you need this to be down, because if you're going positive on the y-axis, you're going to be going down. If you're going negative on the y-axis, you're going to be going up. And you go up, so that's kind of how that works. And then we're also going to have to return this. We're going to have to return the input, and we're going to have to normalize it. Just like so. So we just need to return the variable, so whenever we call a function, wherever. We're actually going to call it right here. So input equals, which is a variable. So input is a variable which is a vector 2, but input is going to equal the input, right? Basically, it's going to whatever. So basically, if input is equal to vector 2 at 0, then we're going to also check if our velocity, so if our velocity dot root is greater than our friction, which is our variable, which is like 600 times our delta, which is constant. And then in this equation, we're going to also make sure velocity minus equals our velocity dot y. And I'm going to explain all this here in just a minute. Friction, and we're going to have to also times this by delta. So technically we could make friction times delta, we can make this some type of variable, but it doesn't really matter. It's not that big of a deal. And we're getting an error. I don't know where the error would be. Oh, right there. We have a comma instead of a dot, just like so, right? So if velocity.length. All right, let me finish it off before. So else, so we're gonna have to say if velocity.length is not greater than friction.delta, then velocity dot equals a vector 2 dot 0, which basically means we're at a complete stop, right? Because if you look at it, velocity.length, if velocity.length is greater than our friction times delta, means our velocity minus our so okay, wait, let me explain. So we have our player movement, right? So we get our input, we get negative x or a positive y, just depending on our sudden stop, right? It slowly decreases. Then, if velocity.length is less than our friction times our delta, so it's basically if it's less than our friction, which means like 600, you can't minus 600 from 500, right? Because it'd be a negative, it would go the other way. So if it's under it or if it's equal to it, then it's gonna say velocity equals vector 2 dot 0, right? So then that basically, as soon as it goes under our friction speed, it's gonna put us at a dead stop, if that makes sense. And then, if we implement this many times, then I'll try to explain a better way in the text. But then we're also gonna want to do else because if input is not equal to 0, which means we have input, then so we're either gonna have to be moving somewhere from our players inputting something, then we'll do velocity equals or plus equals our input. So this is our direction basically. So if we're going up, down, left, right, that's how we're gonna know from there. Times our acceleration times delta, and then velocity equals velocity dot limit length. Which limit length is the new function for clamp. So if you remember the old if we're going right or left or up or down. all Godots in the past, and we also have a collision shape 2D, which we're gonna also need for a player. And as you can see with the collision shape, I know this has changed. In old Godot, whenever you pull this, it used to expand this side and this side.